Well, we got some more algebra essentials. Solving a quadratic equation is something you have to be able to do in any math course, basic algebra, trig, calculus. There's several methods for solving, and you should know every one, even though the easiest one to use is factor. If the equation factors, that's the easiest one, easiest approach to take. But there's going to be times where your instructor will tell you to use the method of completing the square or using the quadratic formula. You can also solve it by graphing. So there's about 5 ways to solve it. The main 3 are factoring, completing the square, quadratic formula. So this one does factor. So we're going to do it all three ways. So we're going to try to factor it first. So it's a trinomial. The right side has to be 0 for this to work. Factors of x squared. This will be an x here and an x here. And then we play around with the factors of 6 and 1, 3 and 2, 2 and 3. There's different other methods too that you can use. But I'm going to go with a straightforward one here. Once you've done enough of these, they become automatic for you. So we're going to try the 2 and the 3 factors of 6. Then remember, the whole objective is to come up with this middle term here. So factors of 5, there's only 2 we can try. 1 and 5, 5 and 1. If the sign of the third term is positive, both signs will be whatever the middle term is, assuming the first term is positive. So in this case, these both will be negative. And then factors of 5, we'll try 5 and 1, or 1 and 5. And then just do your check here. Use your formula. 3x times 2x is 6x squared. And inner term here, minus 3x, and over here, minus 10x, that's minus 13x, and then minus 5 times minus 1 is positive 5. Once you have each factor, once you have the factorization done, then the product of 2 factors is 0 if one or both factors is 0. So you simply set each factor equal to 0. So 2x minus 1 can be 0, or 3x minus 5 can be 0. And then you have 2 linear equations now. Isolate the term with the x, add 1 to both sides in the first one, we get 2x is equal to 1. Divide by 2, we get x is equal to 1/2. So that's one possible solution. The next one, again, linear equation. We isolate the variable, add 5 to both sides, I get 3x equal to 5. Divide both sides by 3 to get the coefficient of the x to be 1. Cancel. So x can be 5/3. So the solution for this one is 1/2 and 5/3. And that's what you would expect for a quadratic. At second degree, you expect at most 2 solutions. You could have, though, a repeated solution, or you can have imaginary complex solutions. So that's the solution using factoring. Of course, we have to get the same thing for the other ones. So we got 1/2 and 5/3. And we expect to get the same thing using the other 2 methods. Now you should know your quadratic formula, but here it is. So if this hadn't factored, that would be my next choice. So we go ahead and plug in. X then should equal to, it's in your standard form. This is A, B, C. A is 6, B is minus 13, and C is 5. The standard form of the quadratic equation, ax squared plus bx plus c equals 0. Okay, so minus b. B is negative 13, so minus 13 is at positive 13. And then it's plus or minus. And that's the square root of. So this will be b squared. B is negative 13, so that's parentheses on the negative 13, and you square it, that's 169. And then it's minus 4 times A is 6, times C is 5, and that's over 2 times A is 6, that's 12. And 4 times 6 times 5, that's 120, so 169 minus 120 is 49. 169 minus 4 times 6 times 5 is 120, so it's 49. The square root of 49 is 7. So this is 13 plus or minus 7. That's divided by 12. So 13 and 7 is 20. So we just write it over here. It'll be 20 over 12. This is your x. So 13 plus 7 is 20, and then 13 minus 7 is 6. So this is 6 over 12. 20 over 12 reduces to 5 over 3. Dividing the numerator and denominator by 6. multiplied by 4. 4 into 20 is 5, 4 into 12 is 3, so that's 5/3. And 6 over 12 reduces to 1/2. So we got the answer we expected. We're solving the same equation, so 5/3 and 1/2. That's using the quadratic formula. The next method, we're going to use the method of completing the square. So for the method of completing the square, a couple of ways to do it. One way is just to make the coefficient of the x squared a 1. So I want to divide everything by 6. 0 divided by 6 is 0. And then obviously we want to complete the square. That's why what the name implies, method of completing the square. So what we do is we take that third term over to this side, change the sign. And how do we complete the square? We have the coefficient of the leading term of 1. We take half the coefficient of the middle term. So that's minus 13 over 6 times half. That gives me 12. And then we square this. That gives me 169 over 144. So adding the 169 over 144 to the left side completes the square on the left side. Makes it a perfect square trinomial. But that's only legal if we add the same thing to the other side. So this is in a perfect square. All we have to do here is just put a square here. Take the square root of the first term, that's an x. Whatever this sign is, that's a minus. Take the square root of the last term, that's 13 over 12. Now on the right side, we want to add these, so we want the same denominator. So I multiply 6 by 24. That gives me 144. So multiply the same thing up here, get the same denominator. So now the common denominator is 144. Then 24 times negative 5 give me a minus 120, and 169 is 49. And now we just take the square root of both sides here. So we have x. We have x minus 13 over 12. And then plus or minus the square root of the other side. So we're taking the square root of this side and plus or minus square root of that side. So that'll give us a plus or minus 7 over 12. So x will equal 2. Now we just add 13 over 12 to both sides, so we get x on the other side. So this will be 13 over 12. 13 over 12, add 7 over 12 is 20 over 12. And that gives me the 5/3. We'll get the 5/3. And then 13 over 12 minus 7 over 12 will give me 6 over 12. And that'll give me the 1/2. So we get the same answers. It's x equal to 5/3 and 1/2. Thanks for watching. We'll see you next time.